to record the question so we can post it again. It says like this: Gauss law, which of the following statements about Gauss law are correct? Gauss law, what it says, so you have to, before reading the options, what it says, Gauss law, is that you have any surface that is closed, the integral of E scalar dds over the surface E scalar dds, the integral is the charge inside divided by x sinus 0. This is what it says, Gauss law. The charge inside divided by x sinus 0 is the flux. Okay, this is what it says. So now let's go to read. Let's go to read the different questions. It says, what are the following statements about Gauss law is correct? 1. Gauss law is valid only for symmetric charge distributions such as sphere and cylinder. No, this is wrong. Gauss law is valid for any charge distribution. So let me see. So this is the correct answer. That no, the correct answer is here. Okay. So well, it's true. Gauss law. Sorry. This is true. Gauss law is valid, but not only. Not only is valid for symmetric charge distributions such as sphere, cylinder. So this is true this is false, but if I take the only, it's true. So
that was marked as a correct answer on my exam.
Well, this is false with the only.
But yes, but it's marked as a correct answer on my exam.
So it's a mistake from the system.
On mine is.
So I'm sorry.
Yeah, same here.
I'm sorry. The guy who designed this question, he doesn't know too much physics. This is the conclusion. Okay, so let's go to see the other questions. They say, if he wrote Gauss law is valid and he doesn't write only, is valid for symmetric charge distributions such as sphere and cylinder, you may think that is true. But if he wrote Gauss law is valid only for symmetry, no. You have a surface, any kind of surface, the flux produced by the electrical field that is here inside, the charge that is inside, the flux is equal to the charge inside divided by x sinus 0. It doesn't depend on the symmetry, nothing like this. Second question, the second option, it say you answer. It say the electrical flux passing through a Gaussian surface depends only on the amount of charge, depends only on the amount of charge inside the surface, not on its size or shape. Let me read it. The electrical flux passing through the Gaussian surface depends. The electrical flux depends only on the charge inside and not on its shapes. This is true. It's true. This statement is true because the electrical flux depends on the charge inside. And it say not on his size or shape. Yes, what is the size of the shape? It doesn't depend. For all the shape and all the size, you will have that the flux, if you have this distribution of charge and you create this Gaussian surface, the flux through this surface S1 will be the charge inside divided by x sinus 0. But if you create another surface, different surface with different shape, the flux over S2 will be also the charge inside divided by x sinus 0. So it depends only on the charge inside, it doesn't depend on the shape. So this is true. Okay? Okay, the third question. The third option is say only charge enclosed between a Gaussian surface can produce electrical field at point on that surface. Wow. Only charge enclosed inside the Gaussian surface can, yes, it's true. At a point of the, oh yes, it's true. This is true. Why is true? Because you have the surface. You have the charge inside. You have the flux of the electrical field, E scalar dds. The flux produced by the charge inside is the charge inside divided by epsilon 0. Now imagine that you have an external charge, Q external. Q external will produce a flux on this surface that is negative, but the flux on this side will be positive and will cancel. This charge will not contribute to the flux. You see it clearly? The flux will be negative entering, positive going out, and the flux of any charge outside of the surface will not make any contribution of the flux, because whatever it enters is the same flux that is going out. So charges that are outside of the volume, outside of the sphere, will not contribute to the flux. So let's go to see what happened here. Let me read it again. Only charges enclosed with a Gaussian surface can produce electrical field at a point on the surface. It's true, it's true. Okay, how many true we have for the moment? The first one is false, the second is true, the third one. So let's say, the third statement, if there is no charge inside of a Gaussian surface, the electrical field will be zero at point of the surface. It's false. It's false. It's false. Well, you have, let's say, the reason why it's false. Let's say that you have a positive charge and you make a Gaussian surface here. There is an electrical field on the surface. There is an E here, and there is an E here. There is an E all over. It is true that the flux is zero, but the electrical field is not zero. The electrical field at points at the surface are not zero produced by this charge that is outside. So let me read it again. If there is no charge inside a Gaussian surface, so nothing is inside, the electrical field must be zero. The electrical field, why should be zero? False. Okay? And now let's go to read the last option.
Professor, the one before is false because it says only the charge enclosed can produce an electric field, but the charge outside can also produce an electric field on the surface.
It is true. It is true. It is true. It is true. The only charge enclosed with a Gaussian surface can produce flux. But other charge, this is true. I mean, you are right. This is false. Sorry. Only charge enclosed with a Gaussian surface can produce electrical field at point of that surface. No, this is false. And the thing is here. the reason is here. You have points. At these points, you have electrical field, and not only if you have Q inside will produce an electrical field E produced by the charge inside. So not only the charge that is inside produce electrical field, but only the charge that is inside produce flux. So it's true. You have to read it carefully. Yes, you see that I have read it incorrectly. So it's true. This is false. Okay. And the last question is, if a Gaussian surface is completely inside an electrostatic conductor, the electrical field, an electrostatic conductor, the electrical field must be always zero at all points on that surface. On that surface. Should be zero, yes, should be zero. Why should be zero? Let's go to analyze this. So I have a conductor. I have a conductor of any shape. The conductor have charges, but the charges cannot be in the interior of the conductor because the conductor allows to the charge to move inside. So between them will be repulsions. So the excess of the charge will be on the surface. So I have this conductor, and the charge will be on the surface. Okay, this is the excess of the charge. So I want to use an argument using a Gaussian surface that produce the arguments will produce the conclusion that the electrical field should be zero. And the argument should be like this. Let's say that I make a Gaussian surface like this one. You see like this one? You see the Gaussian surface that I'm creating? Okay. So, through this surface, that is the surface is very, very near to the real surface of the material of the conductor. So, on this surface, the white one, okay, imagine that I'm playing here, I will think like this. If there is an electrical field, the electrical field should be perpendicular to the surface. Should be going like this because, or if you want, should be going like this. Because the charge positive is here, very, very near. So if there is an electrical field, the electrical field should be going like this. So I will apply Gauss' law to this Gaussian surface. And I will say, okay, there is an electric. You see that the Gaussian surface is on the interior of the volume of the conductor. So I will say, okay, the flux is equal to the charge inside divided by epsilon 0. What is the flux? I have supposed that there is an electrical field E. Well, E, the sum of all the E sub I by the area dA sub I, A sub I, this is the flux. And all these are positive, or negative, if you see here, is they are coming in for this positive charge. They are coming to the surface. All the sum is positive, but all the sum should be equal to Q inside divided by epsilon 0. How you fix this equation if the Q inside is 0? The only way is to suppose that there is no electrical field, that E sub I is 0. So E sub I is 0 in the interior of the conductor. So we have created in the interior of the conductor, we have created an argument that say that if you use Gaussian surface, choosing a Gaussian surface that is so near the conductor, so near here, very, very tight, very, very, you see here, very, very in the surface. If there is an electrical field, you have said should be like this, the electrical field, because there is a charge so near the surface that the electrical field will go like this. So the flux E by dA will be all of them, the sum of all dA sub I, E dA, the sum of should be negative. But how can be possible that the sum of E dA sub I, scalar dA sub I, equals the charge inside divided by x equals 0, if this charge inside is 0, because inside of a conductor the charge doesn't live, they live in the exterior of the surface. So the only way is to think that all the E sub I are 0 in the interior. In the interior. Incredible thing to believe, incredible things to believe. This is something that Gauss' law can produce a result that using Coulomb's law you cannot get this answer so immediately. And this is true independently of the shape of the conductor. It is true for all the conductors. So let's go to read the fourth question to see what it say. It say, if a Gaussian surface is completely inside an electrostatic conductor, the electrical field must always be 0 at all points of the interior of the surface. Oh, yes, of the interior of the surface. If we say in the interior of the surface, I will be more happy to say true. But if say just like this, I will be, because at all point of that surface, this question, the guy who created the question, he need to understand something. And what he need to understand is that when you have a conductor, when you have the conductor, the charge lives in the exterior of the surface. So outside, there is an electrical field E. Outside, there is an electrical field E. But inside, the electrical field is 0. So that's why when you create this Gaussian surface very, very tight to the surface, you get to the conclusion that E is 0 inside. But there is charge inside, there is an electrical field outside of the conductor. So I think that this question, they mark it as correct, but I think that they should say in the interior points of the surface, in the volume, inside the volume. But they mark it like true. It looked like but it's not. I'm sorry that I choose this question. This is the answer. Okay, let me end this.